Hello and good day from Montreal, everyone. Bonjour à toutes et à tous. Thank you very much for being with us today, especially on a Friday morning or even Friday evening for many. My name is Maria Manoli. I am the Executive Director of the Institute of Air and Space Law at the Faculty of Law of McGill University, where I'm also completing my PhD. On behalf of the Institute of Air and Space Law, I would like to welcome you to the second episode of our new webinar series. Our episode today will focus on the topic of aviation safety after the B737 MAX case. Before I say a few words about today's episode and about our institute, please allow me to make a formal statement in recognition of the relationship between indigenous peoples and the territory on which McGill University is located. McGill University is located on land which has long served as a site of meeting and exchange amongst indigenous peoples, including the Haudenosaunee and Anishinaabe nations. McGill honors, recognizes, and respects these nations as the traditional stewards of the lands and waters on which we meet today. I would like now to mention some information about the Institute of Air and Space Law for those who don't know us. The Institute was founded in 1951 and celebrates its 70th anniversary this year. The Institute offers graduate level education in aviation and space law through 4 programs, the Graduate Certificate Program, the Master of Laws, and the Doctoral Program, as well as a program for postdoctoral research. It has produced more than 1,200 graduates from more than 120 countries who now occupy key positions in the aviation and space industry, as well as in academia, and who form a robust network of alumni. If you're interested in applying to one of our programs, please note that the application deadline is coming soon on December 15. Going back to our webinar, about a month ago, we hosted our first webinar, which was very successful thanks to our expert speakers and thanks to you, our audience, and which focused on airline bankruptcies, restructurings, and repossessions. Today, we will be discussing a key topic in aviation safety. The B737 MAX accidents and the following investigations and lawsuits left a mark on aircraft airworthiness certification and on the safety of aviation in general. Today's webinar will address this impact and will think of how the lessons learned from the B737 MAX case might be used to improve the future of aviation safety. The topic will be addressed by Dr. John Maris, President of Cert Center Canada, and Mr. Tommaso Sgobba, Executive Director of the International Association for the Advancement of Space Safety, as well as by our commentator, Mr. Bryan DeCouto, Technical Officer at ICAO's Air Navigation Bureau. More information about our speakers will be given by our moderator, Professor Ludwig Weber, in a few moments. Let me now move on to the structure of the webinar. Our speakers will each make a presentation that will be followed by comments from our commentator, and then we will have time for questions and answers. During the Q&A session, we encourage you to speak to ask your questions after having raised your hand. But if you prefer, you can also write your questions and send them to me through the chat. So the Q&A session today will have a hybrid format, and you will be able to ask your questions both orally and in writing. But in each case, please mention your name, affiliation, and the speaker to whom you're addressing the question. Please note that the seminar is being recorded. We would also like to ask you to please maintain your cameras and microphones closed during the session so that we can maintain a good connection. But please, of course, use your cameras and microphones if you want to ask a question during the Q&A session. And with that, I would like to present our moderator, Professor Ludwig Weber. Dr. Weber is a senior legal advisor at ICAO, the International Civil Aviation Organization, and an adjunct professor at McGill University. He received his legal education at the Universities of Heidelberg and here at McGill University. During his career, he has been a legal counsel of IATA, the International Air Transport Association, as well as a director of the Legal Bureau of ICAO from 1995 to 2004. He's the chairman of the board of the International Foundation for Aviation and Development, and he has lectured and published widely in the field. Professor Weber, over to you.
Thank you very much, Maria, for your kind introduction. I'd like to extend a warm welcome to all participants, and I'm very glad to see a lot of familiar names on the screen. So I hope that our webinar will provide some useful information and discussion on today's subject, which deals with the B737 MAX case. This case actually originated from two accidents with very similar characteristics, namely the Lion Air accident in October 2018 and the Ethiopian Airlines accident in March 2019. These two accidents triggered what I would call an avalanche of investigations and also an avalanche of lawsuits. Among the multiple investigations which followed, and here we not only have investigations of the accidents themselves, namely in Indonesia and in Ethiopia by the respective accident investigation entities, but also we had investigations by US Congress, both committees of the House and a committee of the Senate. We also had an investigation of the Department of Transportation in its capacity of oversight bodies to the FAA. We had an investigation of the NTSB. We had an investigation of the Inspector General, and we had an investigation of the Federal Bureau of Investigation on the criminal side of this case. These investigations triggered legislative reform, and in December 2020, the Aircraft Certification, Safety and Accountability Act was adopted by the US Congress. And as a result of that new legislation, we have regulatory reform by the FAA, as recently outlined by the FAA Administrator Dixon on October 21 of this year, just 3 weeks ago, before a congressional committee. Then we had what I call an avalanche of lawsuits, not only by the victims' families against Boeing, but also a lawsuit brought in the form of a class action by 400 pilots against Boeing, and prominently among them, the Southwest Airlines Pilot Association. We then very recently had a civil lawsuit of Boeing shareholders against the board of Boeing, which was authorized by a judge just 2 months ago in September of this year. We have a criminal prosecution for fraud and cover-up against Boeing, which in the meantime has been settled by Boeing for $2.5 billion. And we have a criminal prosecution of the chief test pilot of Boeing, involved in this case, Mr. Mark Faulkner, for fraud on five counts. And this indictment was brought also last month. And I've not even mentioned a civil lawsuit of Boeing shareholders against the Boeing board for lack of oversight, brought in and authorized in September 2021. In this webinar, of course, we cannot focus on all these developments. We will focus on the implications of this case for aviation safety, in particular for airworthiness certification and for the regulatory systems that govern it. As Maria mentioned, we have two distinguished speakers and one commentator. We will have, after their presentations and their comments, we will have first a panel discussion, and then I will open the floor for questions and comments. So let's start with our first speaker, who is Dr. John Maris, who is the president of Cert Center Canada and its US affiliate, Advanced Aerospace Solutions. John has Transport Canada, FAA, and UK airline transport pilot's licenses with multiple tape ratings, including the Boeing 747. John is also, and this is important for our topic, a Transport Canada test pilot delegate and a practicing aeronautical engineer with a PhD in aviation safety and human factors. He is also an associate fellow of the Society of Experimental Test Pilots, fellow of the Canadian Aeronautics and Space Institute, and he currently chairs the Montreal chapter of the Royal Aeronautical Society. And I have not even mentioned the number of prizes and awards that he has won as a result of his professional activities. So John will talk to us about aviation safety after the B737 MAX case, a test pilot's 2020 hindsight perspective. John, the floor is yours.
Thank you very much, Professor. Thank you very much for that glowing and overlong introduction. My fault for not cutting down. We're going to go very, very fast here because there's a lot of technical material that has to do with the legal side as well. I'm going to look at where the law and the technical perspectives overlap. Here's the proud rollout of the 737 MAX. And as you can see, it has two enormous engines that are snuggled up under the wing. That's part of where the problem arose with this aircraft. And it had some new flying qualities, which some people thought needed new training. So the professor just mentioned that the chief test pilot, the chief technical pilot at Boeing is in trouble. And one of the reasons he's in trouble is because of these quotes. There won't be any type of simulator training required to transition from the NG to the MAX. Boeing will not allow that to happen. We'll go face to face with any regulator who tries to make that a requirement. These are quotes. And we'll find out why this individual was saying these things. They seem anathema to the test pilot doctrine of safety and awareness. And as you can see, this is the indictment that he's facing at the moment. He's attempting to save Boeing money, allegedly withholding critical information. So we've seen that Boeing is facing enormous lawsuits, and so let's find out how they got into this position. First of all, these are my opinions. They're not Transport Canada, or I'm not acting as a delegate, so please be aware of that and take it accordingly. I'm going to look at how we certify, what happened to the MAX, the two accidents, and the lessons learned. First of all, certification. Give you an idea what it costs to certify an aircraft. If we look at the top row there, it's of the order of tens of billions of dollars. And not only is certification expensive, but changes to certification are very expensive. In fact, many aircraft programs are bet the company programs. 747, for example, was one such program. So let's look at the MAX. Big engines, bigger than before. They had to be crammed higher up on the wing than the old ones to clear the ground. And so it handled differently. That meant that pilots would need some training. And if the pilots needed training, the simulators would have to be changed and the reference materials would have to be changed. So this is not a matter of is the airplane safe or unsafe? It has nothing to do with that. It has to do with, will Southwest have to now modify its simulators, write new training materials, double qualify pilots for MAX and not MAX. And the repercussions to an airline are in the hundreds of millions of these types of comments. They're not trivial in any sense of the word. So the reason we don't want to train people is not because we want untrained people. It's because if we accept that the aircraft is different enough that we need to train everyone, then now we have to adopt different training programs for different pilots, use simulators, etc. So there was enormous pressure on Boeing to not have recognizable differences between the MAX and the preceding models. So they appropriate the MCAS, which was used in another aircraft, I believe the 767, for different purposes, to try and sidestep these issues. And I don't mean that in a mean way. I mean to skirt around them in a way that was functional. Had it been done successfully, it would have been an elegant way out of it. The pilots would not have known the difference between the MCAS-equipped MAX and the normal 737s, and Southwest wouldn't have had to spend any more money, and that would have been fine. Let's have a look at certification, and you'll see where this went wrong. We intend with certification to do two things: make sure that we basically meet the Cert requirements and standards, and make sure that the system performs its intended function safely and effectively. Intended function is in the eye of the beholder. One could say, which of these is a better vehicle? And of course, the answer is, it depends. In Canada, which is very similar to the States, we have an act that empowers the regulations, that invokes standards that are supported by guidance and advisory material. The Canadian Aeronautics Act has a dual role for the minister, which is interesting because the MAX plays into this. The minister is responsible for regulation and for promotion, which is an absolutely conflicting situation of trying to promote and regulate at the same time. The minister also is in charge of delegation, which allows people like me to act as test pilots for Transport Canada. Now, this conflict of promoting and regulating was taken away from the FAA after the ValueJet crash, where the two functions were split between the NTSB and the FAA. So the FAA has no promote aviation function anymore. And this is where it happened in 1996. So we have bilaterals between FAA, Transport Canada, and IASA. And basically, if there's a dispute that arises, then the various authorities take it up with each other. And of course, the 737 MAX was certified by such a bilateral. I'm going to go very briefly into software certification. And again, its intended function, and does it do what it's supposed to do? How do we show that we meet the requirements of the certification? Well, we can do various things. We can analyze. We can inspect, go and look at the thing. We can see that it's the same as the last one, which may or may not apply. We'll see in a minute. And we can simulate, and finally, we can flight test. Any combination of these things will be used to show that we are meeting our certification requirements. Oh, and we can ground test, of course. This is how you ground test a 787. You can't see clearly in this picture, but the wingtips are the extreme edges of the picture, which is about 25 feet deflection. So if you're wondering if the wings will fall off a 787, if you can still see out of the window and they're not obstructed completely by the wings bending above your head, then no, the wings won't fall off. I won't show you this video, it's a bit long. It's actually showing that test. You can look it up online and look at them when they actually break the wings off. Now let's take a look at software, the MAX. How do we analyze software in the way we tested those wings for bending until they broke? How do we test it to 150% of the expected loads, which is what we do for an airframe? How do we prove the software has a reliability that we need? And the answer is, we can't ever prove these things. All we can do is decide how serious the consequence is and how probable that outcome is. And that is what we call the risk. So this is the part of the 737 MAX that caused all the problem. The angle of attack vanes, which are mounted on the nose of the aircraft right here. On the MCAS, only one vane drove the system. Although the aircraft has two of these, only one drove the system. Here's a complex diagram of how it all worked, but basically the vane goes into a computer, which effectively trims the aircraft with these big wheels that are moving at the same time, which moves the tail to make the handling the way you'd want it to be. Let's look at these accidents and see what happened. Well, Lion Air was the first one. And as we can see from these traces, the airplane started oscillating, and then pitching down until it dove into the ground. This was the MCAS at work, and the crew didn't really know at all what was happening. The Ethiopian folks had a very similar accident, and they knew about MCAS and they'd been briefed, and Boeing alleges that they did not follow procedures. Not completely clear was that the procedures could not have worked as published, and I won't go into the technical details, but that's just the case. What went wrong? This is a short film of what a trim runaway looks like. In other words, it's kind of like an MCAS going wrong, but not, this is the standard thing pilots are used to. So let's see if I can make this play. See those wheels spinning very fast and the pilot aggressively trying to grab them to stop them moving. So it's a pretty obvious situation when that happens. These two wheels spin, the pilots trip them off with these switches, and they can, in the meantime, grab these wheels to stop them. It always skins your knuckles against the metal, but that's what you can do. So this was the first part of the MCAS procedure, and in their safety analysis, Boeing assumed that pilots would react in the same way as a trim runaway, except that's not what the MCAS does. It moves these trim wheels a little bit, and then takes a deep breath and moves them a little bit more, and then takes another deep breath. So it doesn't behave like the pilots were expecting. Now, we talked about hazards before, and Boeing classified these as major hazards. At major hazards, basically, you are not likely to lose the aircraft, kill anyone. You may injure someone because of a G-force or something like that. These classifications were absolutely wrong. The actual correct classification was catastrophic, which is in the worst case, you will lose the aircraft. Here's a major failure condition, a reduction in safety and discomfort, possibly injuries. And that drives the software for the 737 MAX. Now, as designed, it was major. If you look at the red here, this thing was supposed to do a one-time trim of a couple of degrees at the tail and then stop. As it was implemented, it could repeat forever, every 9 seconds, all the way to the limits of the system that they could trim the aircraft. So 5 degrees aircraft nose down. So it had other problems, but the basic thing that happened here is the MCAS had much, much more, actually unlimited authority to control the airplane. Whereas as designed, it was not supposed to have that kind of authority. Now in the new MCAS, they've now reduced the authority back to towards the original design. So what's a catastrophic failure condition? Well, hazardous severe major is where you can fatally injured some people, and then you also have physical distress and large reduction in safety, and then finally catastrophic is where you lose the aircraft. Now let's have a look at the lessons learned. Systems display emergent behaviors which aren't by design. I'll show you some of those in a minute. Small, numerous incremental changes can have an enormous impact over time. Organizations display emergent behavior, and it is extremely risky to incorporate how the pilots will respond as part of your safety case, even though that's inherent in the regulations. What about emergent behavior? Emergent behavior, well, I've got my clock, I've got my batteries, and I've got my wire. When I add this to them, the emergent behavior of the complete system is nothing like any of its components. So if I make a time bomb out of all these components, it has nothing to do with the behavior of each individual component analyzed separately. So think of the MCAS behaving as the collection of these parts as opposed to the sum of the individual parts. And this is the collective result. So the emergent behavior was unexpectedly to Boeing, going back to this table, this system would not just run and stop. It would run, stop, run, stop, run, stop until it had gone beyond the pilot's ability to override. Looking at the second element, incremental changes. This is a family tree from the 737, and it's allowed to be certified under the same type certificate. Having a look at the aircraft sizes, the latter ones are almost twice the size, almost twice the thrust. And look at the cockpits, old at the top, new at the bottom. Completely unrecognizable, and yet more or less certified under the same type certificate. It's okay from one model to the next, but when you add all those increments together, here's a comparison. 180,000 pound airplane versus 110,000 pound, 144 feet long versus 94 feet long, 28,000 pounds of thrust versus close to 60,000 pounds of thrust. Very difficult to think of these as the same airplane. So, organizational behavior. In an attempt to save money for Boeing, and this is company fidelity that Faulkner was showing, he withheld critical information. He wasn't saying we need untrained pilots, let them take their chances. He was saying that the MCAS should handle the system and we can avoid all the expense that I showed at the beginning. And in this, he was wrong and it was bad judgment. I don't think this was an evil act. I think it was a very ill-considered one. But that went through the whole company and eventually to the point where he actually, although he understood there were real issues, he withheld that information from the regulators. So that's where he crossed the line completely from company man to well, potential indicted criminal. Last lesson learned, and I'm almost done here. The regulations repeatedly state that a pilot mustn't have to exhibit more than average skill, should certainly not have exceptional skill, and the system response should be predictable to the pilot. When I do flight test work, one of the things I have to do is not act like I've done 100 practices at this one maneuver, but try and put myself in the shoes of someone who's flying his or her fifth flight of the evening, having had no lunch or dinner in bad weather with a co-pilot that doesn't seem to be on the ball. That's the situation we should be designing for. So in the time available, the regulation says that we should not have required exceptional pilot skill or strength. And it turns out that both would have been required to implement the Boeing procedures after a few seconds with the MCAS. That's why Ethiopia went down, because they tried the Boeing procedure and it didn't work because they couldn't physically move the trim wheels. So we're back to where we started. Faulkner was trying to save Boeing money, well-intentioned. The documents did not have MCAS reference, nor were the pilot training materials comprehensive. It was a few minutes on an iPad. And this is what was found by one of the congressional studies, but it was because the emphasis was supposed to be with similarity with the previous aircraft. It wasn't a lack of caring about pilots or their ability. It was to try and emphasize just how much this was the same as the old aircraft. So that's where I would like to end it. I'll be happy to engage in questions later, but I think you can see that this very complex interchange of technology, procedures, regulatory imperatives, cost, marketing, and everything else came together for the perfect storm with the Boeing 737 MAX. Thank you for your time.
Thank you very much, John, for a very succinct and highly interesting presentation. Without transition, we will go straight into the next presentation, which will be provided by Tommaso Sgobba, who is Executive Director of the International Association for the Advancement of Space Safety. Tommaso has been the IASS co-founder and first president. Until 2013, Tommaso was head of the Independent Safety Office of the European Space Agency. But I should point out that in his previous life, Tommaso had an aviation engineer background who was with Lufthansa Technik in Hamburg, later with Aeritalia in Italy. And he also worked on the Boeing B737 program development. He later joined Fiat Avio as head of quality control for the Rolls-Royce Avio military space jet engine program. And as mentioned, as from 1989, he was a staff member of ESA at the European Space Research and Technology Center, ESTEC in Nordwijk. In this capacity, he was involved in the development of the Ariane 5 launcher, as well as the European Hermes spaceplane. He participated also in the European manned missions on the shuttle and on the MIR, the Mir station, and was also involved with research facilities of the International Space Station ISS. Tommaso holds a Master of Science in Aeronautical Engineering from the Polytechnic of Turin in Italy, where he was also professor of space system safety from 1999 to 2001. Tommaso received a number of recognition awards for his outstanding contribution to the International Space Station, and also the prestigious NASA Spaceflight Awareness Award in 2007. His presentation will be on the topic of B737 MAX and the crash of the regulatory system. Tommaso, the floor is yours.
Thank you very much, Ludwig, for the nice introduction. Let's share my presentation. I will look again, for what John has been talking about in the last half an hour, but from a small difference in terms of first of all, we have to say that all major, including shipbuilding, traditionally an industry which works on the evolution of the system, are transitioning from so-called prescriptive requirement to performance requirement. So they are transitioning from requirement which provide detailed, let's say, instructions about detailed design requirement and possibly even design solution, to performance requirement which instead indicate what are the aim of safety-wise that the system design should achieve. This is an important, let's say, note, because has been for many years an evolutionary industry, and at a certain point it starts evolving much more rapidly with the introduction, basically, of automation. Until the 70s, when I was working in industry, up to the beginning of the 80s, every control of the engine, of the flight, let's say, itself, etc., was managed through mechanical items. From the 80s on, this was changed with the introduction in many of these functions of computers. Okay, so at a certain point, an industry that was evolutionary had to adapt to a new setup. So what is the difference between prescriptive and performance standard? As I mentioned, a prescriptive standard is a standard that tells you in detail how you should design your system, while performance standard is a standard that specifies the outcome required in terms of safety level. So what is the safety that your system must achieve? The advantages of prescriptive requirement standards is very clear. You follow the rules, you apply the rules. These are inspected, tested, as John was saying, by similarity or by inspection and flight test, etc. And then you comply with the rules and the game is done. There is no need for you as industry to think if something is good or not. There is an example which I always mention about how prescriptive standard fail. Generally, prescriptive standards are issued with a certain state-of-art technology in mind. So the example that I mentioned is the one of the Titanic, which sank, many of you will know, in 1912. And 1,500 people lost their life because there were no sufficient lifeboats on board. And this was because the requirement about the number, very specific prescriptive requirement about the number of lifeboats on board had been established something like 20 and more years before, based on a tonnage that at that time was the limit. So prescriptive requirements tend to become obsolete because they basically are taking into account the technology of the time. They are not very good into anticipating the future evolution. So what we call a rules-based design is a design of a system which is done according to the prescriptive standard. What counts is the experience, and unfortunately experience in most of the cases means bad experience, accident, etc. And from the application of the rules, you get, the design of your system. Then the regulatory authority does the inspection and testing to prove that you are complying with the system. Now, performance standard, the other kind of standard, the one that was introduced to facilitate innovation and for industry like space of nuclear weapons, where there was no previous experience and no willingness to accumulate experience through accidents. Performance standard instead provide either a quantitative target, the failure rate of the loss of the system and the dose on board should be less than one in a million flights, for example. So either quantitative requirement or qualitative requirement, which basically tell you that the system design should aim for what we call, for example, fail-safe or fault tolerance in general, which is basically the possibility that one part of the system fails, but the other part of the system take over and continue the functionality. The advantages of the performance standard is that they are generic, they are not linked to a specific technology, but at the same time, they do not present, a sort of checklist about how you have to comply with the system, because the way you go from the rules to the detailed design requires in the between the rules and detailed design to perform hazard analysis. What is an hazard analysis? It's very simple, is the investigation of a potential condition that, as the design is done, could lead to an accident. This is an hazard analysis. So nowadays, for innovative system, very advanced system, you have fault tolerance requirement. Then you perform an hazard analysis and identify, what are the potential conditions that can lead to a failure. And then it is up to the designer to find the design solution which will meet the objective of the performance requirement. What is now the big difficulty linked to performance requirement? You need clients, a team that can validate the design in terms of meeting the objective. So the team that has to evaluate the design must have not only capabilities of, checking analysis, inspection, test result, etc., but they truly must have the capability to judge the overall design as able to meet the objective. And this has mean that this team needs to have skills and capabilities equal, if not better, of the design team. The case of the MICAS, I will go very quickly. The Boeing 737 entered service in 1967, so it is already more than 50 years in operation and has been evolving continuously. And when it was conceived, the system, the B737, was meant to operate at airport that would have not, sophisticated ground facilities. So the companies, the airlines, and Lufthansa, in fact, was the launch airline for the B737, they want an airplane that would sit very low with reference to the ground, so to have the possibility to deploy their own staircase for, embarking, disembarking the passenger. And this gave to the Boeing 737 a very typical configuration. And here is where the problem started in terms of evolution, because the engines in the last 50 years and more have been evolving under various aspects, but physically becoming wider and wider and wider diameter. And this was creating a conflict with the low, attitude of the aircraft when on ground, such that when finally the engines were selected for the future version that was the B737 MAX, there was only one possibility to place those engines on the airplane, and was to move them ahead of the wing and a bit higher. By doing this, Boeing basically altered what is the intrinsic stability of the airplane. And this is when they introduced MICAS to avoid that the airplane during certain maneuver could exceed a certain altitude and therefore go into a very dangerous situation, which is called stall. Now, I mentioned automation. Automation in aviation started in 1980, and basically the idea was very simple: no longer physical, mechanical, and sometimes hydraulic connection between flight controls and the pilot input, or between the pilot input and the engine, and instead a data bus computer. Now the problem with the computer is very simple. We don't have requirement at that time, and we don't have today, and we will not have in the future, to say exactly as a new system should be designed to be safe. So we can say what the system has to achieve. So we can give performance requirement, but we cannot give detailed prescriptive requirement. The computer have one characteristic: you cannot be 100% sure that they will be always working, well. So from this comes the necessity to have a second computer doing the same function of the primary one, and then you need a third computer to compare the result of the first and the second, and sometimes you need a fourth one if you wanted to continue your operation, so-called failure operation. So the architecture that you have to realize when you have automatic system can become really complex. But this complexity, of course, is one that is reserved for systems that are safety critical. Now, if you fail to properly categorize, classify the function in terms of criticality, here there is the risk that basically was the one of the B737. So what happened with the 737? That there were performance requirements assigned, which were values attached to the idea that the function was not catastrophic, but was major. This conceptual mistake was possible because by using the previous rationale, the one used during the traditional design of airplane, it was considered that the pilot intervention would have been basically able to control the events, what John referred to as the runaway of the elevator, and this basically would have avoided the catastrophe. So there was a conceptual mistake done into the development of the MICAS for the B737, and was the one to consider that a risk mitigation measure, that was the intervention of the pilot, was truly used to change the classification of the risk. And we can have some example about how this is completely wrong, but for the sake of time, I will proceed. So basically, with the introduction of automation, the design of computer-based system in aviation changed from the implementation of detailed design requirement and design solution into the performance of a failure analysis to show that basically the system, the computerized system, had the same reliability that could have been expected with a mechanical system. Therefore, the verification of the compliance of a computer-based system with the requirement became a matter of assessing the criticality of the function. So basically, what was wrong with this overall approach was the attempt of keeping the same logic used for previously when everything was mechanical on an airplane, and dividing basically mechanical failure from the training of the pilot, etc., to keep this approach still with the automatic system. This has been basically the flow. And as I mentioned, an additional and fundamental flow has been the one to use the risk mitigation, that is the pilot intervention, as a way of changing the classification of the function itself. Okay, so the overall approach is therefore in question. Nowadays, apart all the relevant and the very important point that has been raised by John in his presentation, which are totally valid and true, there is a fundamental problem. And the fundamental problem is that to manage a complex system in aviation, we need to analyze the system in its entirety and with reference to the various interconnection. So we cannot separate hardware from software and from the human, but the hazard analysis, the safety analysis must keep all the three elements into account. What I tell you is the right way, in my view, to do things is basically the way the space station has been built. The space station has been built by using performance requirement and by using integrated hazard analysis, which did not separate between the human, the hardware, and the software, and addressed the relevant risk mitigation holistically. Finally, there is one point that needs to be said, and is the following. In the last 50 years, 70 years, we could say, the regulatory had enormous difficulty in, let's say, maintaining the skill and the resources to check the certification of major development like Boeing 737 or Boeing 777, Airbus, and so on. So basically, what happened? There was a delegation approach up to the point that as of 2018, 94% of the certification activity for a system, I mean, Boeing airplane, is done by Boeing itself, 94%. So, and this is with a complexity related to a large extent with a prescriptive requirement, then the introduction of performance requirement. The more we go into the performance arena, the more we risk to have inadequate resources at the regulatory bodies. What basically is the proposal that my association has been advanced in other fields, in the space field, is to create between the regulatory body and the industry an intermediate, let's say, organization, technical-oriented organization, not permanently staffed by the same technical people and scientists, etc., but which would basically call the expertise of selected people as their current and updated knowledge of the new technologies. So not a new bureaucracy, technical bureaucracy, but an organization that could bring the best of the knowledge from industry, regulatory, academy, to work together as a validation team for new design. The conclusion of all this is the following. The current airworthiness standard are either antiquated or inadequate. And therefore, we need not only to look into the numbers, but we need truly to look into the system design. And for this, we need to de-emphasize quantitative requirement and instead prefer qualitative requirement. And I am glad to see that the administrator of FAA announced a few days ago that they will do exactly this. They will have more emphasis on fault tolerance and fail safe for all safety critical function, and basically use the quantitative analysis as an additional support and not as the primary logic. Secondly, today we have this separation between hardware, software, and human that are considered separate, and this needs to be reconciled reconciled. Therefore, in aviation, we need to introduce updated technique for hazard analysis. And finally, because of the difficulty that has been mentioned and are well known in terms of skill and human resources, updated human resources, it is necessary to reconsider the way, and the kind of activity that a regulator can do. And from here, the proposal that I mentioned before. Thank you very much for your attention.
Thank you, Tommaso, for a highly informative presentation. And thank you also for putting in your conclusions a focus on the effects of the widening gap regarding skills and resources between the manufacturers on the one hand and the regulator on the other hand. And of course, there will be opportunity to discuss your conclusions. We now will have Bryan DeCouto from ICAO, who will comment on the two presentations, and I assume from the particular perspective of ICAO. Bryan DeCouto is Technical Officer, Certification and Oversight in the Air Navigation Bureau of ICAO. He was previously the Implementation Support Officer, Safety, and in his previous life, he was Airworthiness Inspector for the Bermuda Civil Aviation Authority for 13 years. He holds degrees from Concordia University, the École Nationale de l'Aviation Civile, and from the Florida Institute of Technology. So I invite Bryan to comment on the two presentations and, if appropriate, ask some questions. Bryan, please.
Okay, thank you, Dr. Weber. Thank you for the introduction. And a big thank you as well to Dr. Morris and Mr. Sgobba for their very interesting and informative presentations. And thank you to McGill University for the opportunity to speak today at this webinar. And I'm very happy to be here and share my comments with everyone. So I just wanted to start by saying, whenever there are aircraft accidents, particularly those as tragic as the 737 MAX accidents talked about here, it's very vital that we find out the causes and lessons learned through the accident investigations, so that we can take actions to prevent this from ever happening again. And I think both presenters did a really great job of identifying some of those lessons learned, and also looking deep at possible root causes and proposing ways forward to make the performance-based design process more safe. So performance-based certification and oversight, it looks at the standards as an objective which needs to be met. And it has, as we've heard, I think it has many benefits over prescriptive-based standards, such as more flexibility, providing more flexibility when we're talking about innovation and new technologies. It also reduces certification time and costs, and it can make more efficient use of resources, while hopefully maintaining a similar level of safety. But it does have weaknesses too, as we've heard today. And I think one of the biggest weaknesses of performance-based certification is in relation to the subjectiveness of the requirements and the challenge with being able to properly define what compliance looks like. It can make it very challenging to implement the requirements on a consistent basis. I also think a good point touched on by both presenters is that when it comes to conducting, the necessary hazard analysis, there is a lot of dependence on the subject matter expert who's going to make the decisions to identify and classify those risks. So if that person doesn't have the proper knowledge, or if that person is I don't know, somehow compromised or complacent or biased or has a conflict of interest, it can certainly introduce a risk to the system. So, for example, someone can classify something as major risk, while another may classify it as catastrophic, as the example we heard today. So after an accident, it becomes obvious how it should have been classified. But before that, it may not have been so obvious. So this can put a burden on, of course, the regulators as well to review and oversee these processes. And that's what's really, I think, difficult with performance-based standards. It's, how do we consistently apply it? So I think in John's presentation, he also pointed to the unique problems posed by software certification, and particularly with regards to how software interacts with hardware and the pilots. And I think Tommaso mentioned this as well. And it's clear this is a big challenge for the manufacturer and for the regulator. And it's only going to become more challenging as technology continues to evolve and there's more and more reliance on software and automation. So, how do we solve these challenges with performance-based standards? How do we take the lessons learned from these events and improve the certification system? So I think one idea, which I thought was a great idea, proposed from Tommaso, is to set up an independent multidisciplinary group or panel to support the state's certification activities. So this could, I think this could help to ensure that aviation authorities do have access to people with the right knowledge and skills, and it will provide an independent review of the hazard analysis. And in theory, this could work well. And Tommaso said there's precedence in other industries as well of this working. So I look forward to further discussion on that. And I would ask, how do we make that happen and work properly and effectively? And my other question is, if this group is going to be made up of seconded staff, from the industry, from the manufacturers, how do we avoid potential conflicts of interest? And there could also be issues with manufacturers' lack of willingness to share proprietary information. So they might not want to cooperate completely. And also, how do we prevent decisions made on commercial advantages as well, if they have a gain, somehow commercially? So maybe later, maybe Tommaso can share his thoughts on that. And I'll just finish up on my comments by saying, at ICAO, at the International Civil Aviation Organization, we're working hard to enhance the performance-based standards in the ICAO annexes, and in particular Annex 8, which contains the global standards for airworthiness and aircraft design certification. So I think some of the issues and ideas presented today in relation to performance-based standards, I'm certainly going to be taking back to my bosses. I think there's some great issues raised and ideas. And then maybe we can incorporate it better to improve Annex 8 down the road. So my last question for the presenters would be, what else could ICAO do in your opinion to help improve the implementation of performance-based standards globally? So I'll just leave you with that, and I just want to thank you again for such great presentations. And back to Dr. Weber. Back to you.
Thank you very much, Bryan, for your insightful and very useful comments. I would now invite each of the speakers to perhaps address those comments and particularly also address the questions which Bryan has raised. So shall we start with John? Please, if you can comment and address also the questions.
Okay, thank you, Professor. Bryan, excellent points across the board. Unfortunately, some of these issues that you raise are built in not just to the system, but to humanity. Let me take conflict of interest. Someone is being paid within a company to determine the airworthiness of an aircraft, even before the FAA or Transport Canada gets that. All of us that are delegated are being paid by somebody to make airworthiness findings. And so ultimately, that conflict of interest is built in. And if there's an independent body, they are going to be composed of experts, typically, that probably come from that industry. Noting just how the performance versus prescriptive standards go, technically in the FAA rule world, we don't have performance-based standards for large aircraft, for air transport size aircraft. We have it for Part 23, which is the general aviation aircraft. And interestingly, the means of compliance for those performance-based standards are derived by a group called ASTM, which is composed of industry experts that are not necessarily independent, but at least for every Piper person, there'll be someone from Cirrus, and from every, it would be analogous to every Airbus person having a Boeing person on the board. So ASTM maintains its independence only by the fact that it is comprised of multiple independent organizations. The last point I'll make as a test pilot is, how do you evaluate something that's performance-based objectively? And the answer is there are multiple techniques that can be applied, because we simply cannot in this day and age, performance-based or prescriptively say, well, that felt right, so I'll sign it off. So we actually have techniques to be able to score and rate aircraft and their characteristics within 1 or 2 points out of 10 for every test pilot that will put that aircraft through the procedure. So it's about making those criteria well-defined. I'm going to give you one area, and I will share the screen momentarily if I can make this work, to show this, to demonstrate this. Let me just see this, if this works. I won't bother to go into slideshow view, but can you see my slide here properly, Maria? Are you seeing my slide?
Yes, we can see it.
Yeah. So both Tommaso and myself refer to hazardous conditions and everything else, and we tend to view these as essay exam questions. But actually, if you look at the wording of how it's categorized, there should not be any controversy or misinterpretation. So, for example, if you look at this third bullet here, or third paragraph, hazardous adverse effects have serious or potentially fatal injuries to a small number of those occupants in the airplane. So I can't say something is hazardous if it will kill everyone, or if it will severely injure many, many people. If no one is injured, they're just uncomfortable, I'm probably not up at hazardous. And it goes into every one of these classifications. A major failure condition talks about reductions in safety margins and increases in workload, discomfort to occupants, and possible injuries. So if you see what I'm saying, when you operationalize these characteristics, every word matters, and the legal experts among you will spend a lot of time trying to find out what the right words are to properly define everything in a way that is reproducible and not subjective and open to pressures and interpretation to suit the company. Thank you.
Thank you, John. I will now invite Tommaso to also comment.
Yes.
Please, Tommaso.
I like very much to comment about this, because in the space field, we have accumulated substantial experience in how to deal with performance requirement and how to deal with subjectivity, for example, and things like this. So what we did with the shuttle payloads, I have to remind those that are not completely aware that the shuttle was meant to transport to orbit big satellites like the Hubble telescope or upper stages for further, orbital injection of payloads, habitable module, etc. So the requirements for payloads to be carried by the shuttle were requirements about a rather complex system. Nevertheless, because this system had been and were in progress of being developed by other organizations, the requirements were performance-oriented and not how you designed the shuttle, the Hubble telescope. How the problem of subjectivity was dealt with? In two ways. One, there was a collection of so-called interpretation letters. So NASA periodically, as the need arises, issued the interpretation letter explaining better the intent of the requirement, and in some cases, ways of meeting that requirement that could be considered acceptable. Not the only way of doing it, but a way that was customary to do it and would be acceptable. This was a set of documents, interpretation letter, very clear also in the title, the meaning of this. Then there was another set of documents that were not publicly distributed, like the interpretation letter, which were available to anybody very publicly. There were the so-called policy letters. And the policy letters were basically studies performed by a dedicated team at NASA on a case-by-case basis to answer question of acceptability of design solution that were rather complex and or innovative. So these policy letters were basically recommendation to the panel about what the panel had to request when this kind of solution were presented. And this meant a big book. It was a big book of this policy letter. So how you deal with proposed design solution like this and that, okay? Then there was training. The panel was trained to develop a common culture. For example, we had to develop a common culture about what was a credible failure. Because you can postulate any, and this was the result of internal discussion, and eventually the panel determined, okay, our understanding of credible failure is this, and this is what was the result of training and exchange of information within the panel. And this is about subjectivity. To give you an idea, the panel at NASA, the shuttle payload safety review panel at NASA, at a certain point was replicated in Europe, and I was in charge of the panel in Europe. And then we developed a project that was called franchising. And the objective of the project was to make sure that a payload that was reviewed in Houston would result in very similar type of action items as if it was reviewed in the Netherlands, okay? And this required an exchange of information and familiarization period of the staff in the two locations, and so on. So this is about subjectivity. Subjectivity will be there, but there are ways, proven ways, to reduce dramatically the level of subjectivity. About the conflict of interest, nowadays the certification, 94% of the certification of a Boeing airplane is done by Boeing people, okay? So I don't believe that there is a bigger conflict of interest than this one. In any case, we have to recognize two facts: that when we put now into a team Boeing people, with Lockheed people, expert in specific field of the engineering. I don't see truly these people that perhaps have, they know each other because they are leading experts into the field, really inventing or creating issues that are not there. They may have their own opinion, strong opinion, but not this. On top of this, the way the safety panel, this independent safety panel were organized was that the authority was in a single person that had to be independent, the chair of the panel. So all the experts into the panel, the various experts in the various branches, they were eventually making recommendation to the chair, but the final disposition and decision was of an independent person that was the chair. And the chair, you can imagine, could be someone close to the regulatory organization. So someone that can listen to different, may not have the detailed knowledge, but can listen, to the arguments and can decide what is, a reasonable way ahead. And this is about the conflict of interest, proprietary information. Whenever we had reviews for the space shuttle payloads and for the space station, etc., there were a lot of data that were distributed to the several tens and sometimes 100 people that were involved into these activities. We made an effort, and this was written down in a specific procedure, asking the company to identify those specific passages that were proprietary. We said, please don't cover the entire design with proprietary, because it is not. You have to tell us exactly this page from this point to this other point, this is proprietary. And for this, there were rules, non-disclosure declaration from the various members and commitment, etc., that made sure that the information that was given to a panel member would absolutely remain with the panel member unless he was risking, to be rejected by the panel or even taken disciplinary action and things like this. So there is a certain experience in space about how to deal with the matter of verifying compliance with performance requirement through the use of large multidisciplinary team of subject matter experts.
Thank you very much, Tommaso, for those comments. And indeed, it is an instance where experience from space could be useful for the regulatory environment in aviation. And perhaps this may be a subject that we could discuss further. At this point, are there any reactions either from John or from Bryan?
If I may, Dr. Weber, just to thank them both for those explanations. It's very, very, very interesting, and like you said, it really deserves further discussion, and I look forward to those discussions. And it sounds like there's a lot of things to learn from the space industry. We don't have to reinvent the wheel for aviation, let's say, and a lot of I heard a lot of good strategies on how to deal with these issues. So that's really great. So thanks again to John and Tommaso.
I would like to make
Tommaso?
a further comment.
Yes.
Yeah, I would like to make a further comment. Yes, which is the following. In the last several years, I would say 3-4 years, we have been working very much around this topic in space, because due to the commercial evolution of the space industry, very soon FAA, AST, which is a branch of FAA for launch and re-entry, may have responsibility for the safety of those on board. Nowadays, there is a moratorium, so they cannot do anything. And so the problem was, okay, this is a team of 100 people. How they can, bring into this arena the kind of knowledge that was readily available in NASA. And so we studied this concept. We studied the concept of a Space Safety Institute, the way we call it. And let's say the first step to establish a Space Safety Institute was announced in April of this year by the Aerospace Corporation, which is the largest FFRDC in US, at the United Nations COPWAS meeting in Vienna. So at this moment in the space industry, we are progressing with the creation of something like a safety institute, okay? And there is a website of the Aerospace Corporation called Space Safety Institute. They are still in the initial part. They are very much concentrating in this moment on public safety matter, launch, re-entry, etc. But basically, the problem about how to support the regulator that has no scientific, technical background of the kind that is required today, this is a problem that we have been discussing. If ICAO wants to know more about this, George Nield, the former Associate Administrator of FAA-AST, has been very much involved in developing this concept, in evaluating and developing this concept, so could be asked to contribute with comments about this. And this is one very last comment, if I can. Please note that if today we have flight-by-wire, we have a FADEC, and all the rest in aviation, is because this kind of system were inaugurated on the shuttle. So the shuttle was the first aerospace system of all time historically to introduce fly-by-wire in the. So that experience is still valid, evolved a lot because the digital, let's say, knowledge evolved a lot, but the fundamentals are still there. And so we have some commonality that goes beyond the procedure, also technically. Fly-by-wire, etc., started with the shuttle. Yeah, thank you.
Thank you, Tommaso. Any comment from John?
I do have just a couple of comments briefly. One is, again, to go back to the conflict of interest. I think it's a very important one, but I need to make it clear. When a certifier, whether it's an FAA or a delegate or a third-party expert, makes a finding of compliance, whether they are conflicted or not, they are doing so with the full expert knowledge that what they have approved is going to be out there and might be flying their daughter 5 years from now. We have absolutely no incentive under this or any other organizational setup to violate the trust that people have in what we certify, any more than an engineer that builds a bridge who might have a conflict to save money, cut costs, whatever, but ultimately they understand that their family might be crossing that bridge. So although it seems like a very strong imperative, I don't think the conflict of interest was the main driver of what happened to the MAX. There was some element of it. Loyalty to the company was some element, but I don't think it was a straight, I'll make a decision because it serves me better because I'm in this conflict. It's easy to, from standing on the sidelines, it's easy to think that's what's going on. But the other point I will make, and this is really important, nobody knows the system better than the designer to do the first part of the certification. In fact, the certification authorities don't even get involved until the Boeings of the world have done a huge amount of work. And it would be completely impractical to get into the very deep details of the certification completely independently without having a very large reliance on the manufacturer. It's just not, if you think of how big Boeing is or Airbus, and try and duplicate that level of effort to have that level of understanding across the board, it's not feasible. So that's why the system has these checks and balances and compromises. Didn't work in the MAX case for sure, but overall it does work, and it works very well. And you know, for what it's worth, Concorde was flying with fly-by-wire as well, and it didn't ever have any issues with that. So that's my comment there.
Thank you, John, for those comments. And before I open the discussion to the participants, any last comments from anyone from the panel? No, that does not seem to be
Weber,
the case.
I'll just say thank you again to John and Tommaso, and just on the conflict of interest. Thanks for the views on that, and I think it just sounds like, I mean, it's just a matter of properly managing. You know, like John said, with human nature, those risks can always be there, but it just takes, I guess, proper management for a company to manage that and document any conflict and reliance on individuals to be professional and experts and have a drive to want the product to be safe. So I understand what John is saying there. So thank you.
Thank you very much, Bryan. I will now open the floor for questions or comments from the participants. And as Maria pointed out at the beginning, you have two ways of doing that, either by raising your yellow hand, and I already see a number of yellow hands on my screen, or you may also send a question in writing on the chat function to Maria, and then when that happens, Maria will pick up the question and read it. I will ask each participant to state his or her name, affiliation, and also please mention to which speaker the question is directed. After asking your question, and please, before you ask the question, don't forget to unmute. After asking your questions, I will ask you to again mute so that we don't have background noise in the microphone. So I will now call on the first participant to raise his question. Philippe Doyen-Poulain, please.
Yeah, hello. My name is Philippe Doyen-Poulain. I'm a professor in human factors and aviation from Polytechnique Montreal. These opinions are my own, so I just want to put it out firsthand. Thank you very much to Dr. Maris, Professor Tommaso for this presentation. Very informative. I think one aspect that we should be talking about as part of this panel is the grandfather clause. So the fact that in certification, once you have an initial type cert, you only need to recertify whatever you modified on a new model or aircraft. This is why the 737 MAX is still running on the same type certificate as the original 737 from 1964. So basically, I mean, we're having a, I would go as far as saying that we have a middle of the century aircraft flying in 2021. And still, this is all as per certification. Now, this condition of the grandfather clause and the immense resources invested in certification, as presented by Dr. Maris, put a lot of, let's say, insist a cultural an organizational culture, whereas engineering wants to minimize change. So we want to change as less as we can. Otherwise, we will need to recertify it, and as you see, the cost of doing so is a disincentive. Another difficulty that we should be talking about regarding aircraft certification is some strange behavior from a pilot perspective are working 100% compliant with their certification. Just for example, the autopilot disengagement. The certification for autopilot disengagement says that there should be a warning to the pilot to tell that the autopilot is disengaged after the fact. So after it disengaged. So that means there's no pre-warning, no situational awareness, no preparation of having to take over control before the fact that, well, actually no one's flying the aircraft right now. This is this exact same behavior as if there would be a two-pilot aircraft, a two-pilot crew with a left seat pilot flying, hands on the stick, heavy weather, Cat 1 condition, gust wind, 1,000 feet above the ground. The pilot just raises his hand up in the air and says, "Your aircraft, I'm off flying." And then the co-pilot has to take over in startle and surprise. This would be unacceptable behavior from an aircraft and a pilot perspective, but the autopilot work behaves just as this way and 100% compliant with the regulation. And so the last point regarding the grandfather clause, the 737 MAX didn't have to comply with the most recent regulation, didn't have to comply with 1302 regarding usability and human factors, didn't have to comply with 1309 for 4751 safety reliability, didn't have to comply with the latest 1322 regarding flight crew alerting, because of the grandfather clause, it's still running on the initial 1964 rules. So I guess these are important topics that we need to be talking about right now, and I already thank McGill Institute for giving us this opportunity.
Thank you very much, Mr. Doyen, for your questions. And I think they were in the first place directed to Tommaso, and then maybe afterwards I will also give John the opportunity to respond to this. Tommaso, please.
I have very little to comment other than saying that, he's absolutely right. And this is something that cannot last for centuries, because this is the trend nowadays. So I absolutely subscribe to what has been said. And this is something that should be somehow taken into consideration by the major certification bodies together, because this is a trend that needs to be encouraged. To try to cooperate more, because the more the certification relies, on this kind of aspect, and the more they needed to have a common culture, common understanding, common practices. So this is my comment. Yeah.
I just want to add,
John,
we need to put in incentive for the. But we just need to put incentive the aircraft manufacturer to be able to update and fix problems.
Are you asking a further question, or are you having a comment?
If it was for me, I just wanted to mention that we need to put in, certification need to put incentive to be able to fix the problem, known problems, open problem report, and to improve the aircraft. So right now, the huge resources involved in making any certification or modification is a disincentive to improving aircrafts.
Okay,
John, please.
May I address some of the comments that are made, Philippe? Some of the things you said are right. Some of them are point blank wrong. Of course, 4754 was applied. Of course, 1309 was applied. Those regulations have been around in the aircraft. Absolutely, I have done analyses on that aircraft in those two contexts. So, it's not called a grandfather clause. It's called the change product rule. And the change product rule doesn't let you just keep the same type certificate. It forces you through a tree where the outcome tells you what certification basis you need. The basic airframe might be under the original certification, but for example, if you change the cockpit and put EFIS and everything else in, that will have the HERF, the lightning requirements, the 1309, the 4754, and the human factors, the 1302, which is a new regulation, relatively applied. So I understand your point, but on the other hand, it is completely infeasible to certify to the latest requirements an aircraft that was certified to the 1950s, because you can't reverse engineering. It's a bit like looking at an omelet and trying to try and figure out what the ingredients of that omelet were once you're looking at it. So it's not that easy. As for the autopilot disengagement, I'm an autopilot test pilot. I don't know how you would want to advise that the autopilot is about to disengage if it's disengaged because of a failure. It's not psychic any more than the pilot is. So autopilot disengagements on the 747, the alarm is so loud that it's almost deafening. It's absolutely impossible for it to disengage without all of the flight crew being thrown out of their seats almost. Preemptive disengagement, most of the aircrafts I fly have dual autopilots, so you know well before the autopilot's disengaged because it will have a disagreement monitor. It will give you alerts that the source data is bad. It's not just an autopilot, it's just not a big on-off switch that trips. I've flown the 747, had triple autopilots that would vote amongst themselves, just like the 5 systems in the space shuttle. So, I mean, I understand the issue, but and we've had autopilot problems that have caused accidents. It's not, I would say, as major an issue as you're making. There are other issues that are much worse in human factors than the autopilots. And as far as the 737 MAX, I want to make one thing clear. What failed was not the processes as written, clumsy and expensive as they are. What failed was the implementation of those processes. If they had been done correctly, the hazard analysis would have come out with a different number, and that design would never have hit the streets. It's not that the processes weren't designed to catch that situation. They failed to do it, just in the same way as sometimes an airbag doesn't work in a car. It's designed to work, and sometimes it doesn't. I'm not disagreeing with Tommaso that we can do much better with our processes. But the existing processes should absolutely have caught the 737 MAX before it hit the streets at all. They absolutely should have. And if I had been presented with that design, I would have rejected it outright from the very beginning for very simple reasons, not because I'm so smart. Thank you.
Thank you very much. Yes, Tommaso?
A quick comment. Truly, the attitude to modify somehow the classification of a function based on the existing and known mitigation, let's say, features is a rather common mistake. Is a culturally embedded. It's like someone saying, you know, I have a parachute which may fail. And when I realize that it has failed, I will operate the reserve parachute, and therefore I could have a hard landing, you know, perhaps injured, but that's okay. So the function, which is parachute function, is a major function. It's not a catastrophic function. So this is a mistake, a logical mistake that people do very frequently. Instead, the logic is the parachute function is catastrophic because it's catastrophic, needs to have a fail-safe or a fault tolerance approach, and therefore needs to have a reserve parachute and, you know, to operate it at the right moment, etc., etc. So it's a common mistake, and people who are not trained to do an hazard analysis can easily make this kind of mistake. So it's absolutely a mistake, but it's very common.
Thank you, Tommaso. We have right now 4 other requests for the floor, and I will take them one by one. And in the interest of being able to take all those requests, I would ask you to be brief when you address them, please. The next speaker that I have is Charles Schlumberger from the World Bank. Charles, please.
Yes, good morning. I'm Charles Schlumberger. I am a graduate of the Institute, 2009 DCL. I'm also in charge of air transportation at the World Bank, and I am an aviator since over 40 years. So I have a technical question. We did not talk about that the aircraft now supposedly is safe. And I had many discussions with people from Boeing and pilots And I have two technical important questions to John. And correct me, but I understood two measures have been taken. Number one, the aircraft now has two angle of attacks. And number two, they went back to the old system where the pilot can overpower, or at least the MCAS doesn't react like it did last flight. It's important for us also the fact we lost one young staff in the crash in Ethiopia. And so I get asked that question often, is it safe? So the question are the following. Number one, when you have two angle of attack, and I have an angle of attack in my Cessna 340, if one is malfunctioning, how does the system know which one is malfunctioning? Because the Airbus 320 with 5 computers, 4 exclude the one that is malfunctioning. And the second question, the MCAS now went back to the situation where a pilot actually can overpower it and stall the aircraft. That exactly was deemed dangerous after the initial certification, and then they went a step further. So we are back to what was considered unsafe. John, is that aircraft now safe or not? Thank you very much.
Okay.
John, please.
Excellent questions. And I have a conflict of interest here, so I'll declare it. I actually was trying to interest Boeing in a third tiebreaker system that would exactly deal with the two angle of attack disagree. I don't know exactly, but I believe what Boeing has done is if the two angle of attacks disagree, and I think they reject them, and that does lead to the question of what does it do to the behavior. It's not so much that the stall behavior of the airplane is unsafe or disastrous. It just doesn't meet the certification regulation. So it's, let's call it undesirable. Is the aircraft safe? I would go on it. I would put my family on it. I don't think it's an ideal solution to the problem they had. I think it's safe simply because the amount of exposure and regulatory oversight and navel gazing that has happened because of these two accidents is extraordinary. And I can't imagine anyone releasing this aircraft for service under any of the national authorities with the slightest doubt as to its efficacy now. And certainly not Boeing having lost $25 billion. I don't think they need to see this problem resurface. So the short answer is yes. From a personal and biased and conflicted opinion, I think the system is still compromised from being ideal, but I think it's safe.
Thank you, John. I will next call on Mr. Juan Lozano to raise his question or comment.
Thank you, Dr. Weber. First of all, I would like to thank you, McGill University, for this opportunity to have these experts here, and thanks to the panelists. My name is Juan Carlos Lozano. I'm an airline pilot, accident investigator, and I'm a member of the FALPA board. I'm here talking on my own, not on any organization's own. I would like to make a brief comment on the presentation of John Maris. I agree with John that probably the behavior of the chief technical pilot of Boeing was not evil. I fully agree with that. But I have to say that this is not what it was expected from him in the position that he's having at Boeing. I mean, everybody would assume that this person would talk about safety first and not about economy. I have a question for the panelists, including Mr. DeCouto. Is that how do you expect certification and standards will evolve in aviation with the introduction of artificial intelligence? Something that maybe Professor Sgobba has more experience from the space technology, but how do you think that will evolve? Thank you very much.
Thank you, Mr. Lozano. I think that all three panelists are addressed, so I will perhaps first give the floor to Tommaso.
Yeah. No, I don't have experience in AI application because they are quite new for me. But I had a few days ago a discussion with a medical doctor who works at FAA, and basically we concurred that the best help from AI would be into the diagnostic. So basically, when something breaks down, you need to isolate the failure and to let the pilot know what is going on. Probably this is something that AI can be doing, okay? Because nowadays, when the automatic system fails, the authority and the control is passed to the pilot has a problem figuring out where the problem is.
Thank you. John, please.
Yeah, but actually, I do happen to have some time on this. I've done AI work with NASA for the last 20 years, including actual flight tests. The biggest single problem with AI is it's not deterministic. So if I have let's say, a terrain collision avoidance system that is going to miss a mountain, and I ask the designer of the AI system, is the plane going to go over it, or will it pass it to the left or pass it to the right? And the AI person can only say, I don't know. It's going to miss it, I promise, but I don't know what it's going to do. Well, that poses huge difficulties for the certification authorities, because what do you test against? So there are a number of working groups, and I'm actually actively involved with NASA, and we're working this. And why does it become important? It becomes increasingly important with unmanned and autonomous vehicles that have to use forms of AI. And the answer is partly to bound the system and what it can do, so that it won't let the airplane do something completely stupid because it divides by zero. But the non-determinism aspect is the one that the authorities, the certification authorities, are really grappling with. Once that's solved, then I think you'll see an increasing amount of AI. We'll need it particularly for the urban air mobility environment, where we have far, far too much traffic for humans to cope.
Thank you, John. Bryan?
Yes, thank you for the question. Very interesting question. Very interesting, and it's a bit beyond my expertise. But I would just say that it's going to take a lot of work, and ICAO has expert groups that are working on these types of issues, and I know we get regular sort of updates on innovation and artificial intelligence, particularly. So so those ICAO standards and things they're going to have to evolve with the innovation and with the technology, and obviously with artificial intelligence, it could introduce a lot of issues that we have to do really proper, good hazard analysis and management of change as well, type of work. So thank you again for the question.
Thank you, Bryan. We will now go to the next participant, or the question, who is Mr. John Irish, please.
Hello, can you hear me?
Yes, we can hear you.
All right, lovely. Thank you. My name's John Irish. I'm a student at the University of West London. Firstly, before I ask the question, thank you all for the very interesting presentations and the points you've made throughout this. I'm really glad I was able to attend. So my question is directed more towards Dr. John Maris, but naturally I'd be happy for any of the other panelists to answer. My question is regarding the chief pilot's actions, the chief test pilot's actions in reducing the amount of training pilots had to undergo for the 737 MAX. Would you say that Boeing's competition with Airbus in the narrow-body aircraft market was one of the reasons that the test pilot was so insistent on not having pilots retrain for the 737 MAX? In other words, do you believe that this aircraft was rushed onto the market in order to overtake or compete with the A321neo?
Okay,
John, please.
Great question, John. I can't comment about the drivers inside Boeing, but I would certainly say that commercial pressures were pivotal I really do believe that Southwest was the instigator of this, and I don't mean it in a mean way. I mean the order with Southwest accepting this aircraft or anticipating this aircraft, the commercial pressure of Southwest not wanting to have a new variant that needed a new type rating or new training or new manuals or new anything. I think that was possibly more of a pressure because they were a Boeing only customer at the time, and I think still are. I think that pressure drove it. But to answer your question, I think commercial pressures absolutely had a role because the MAX had some other issues as well. And I think it was bound to those commercial pressures that the pilot was saying we shouldn't have training. It clearly was not a matter of we want untrained pilots to fly our airplane. That wouldn't make sense no matter how you slice it. And to reply to an earlier comment, I completely agree that the chief technical pilot did cross a line. There's no question that I'm supporting his behavior. I'm just saying that the motivation is probably not as obvious as sort of a criminal intent is all.
Thank you. Tommaso, you want to comment?
Not on this point. Thanks.
Thank you. Bryan?
No, I'm okay. Thanks.
All right. Then we will straight proceed to the next question, who is from Silverio Espinola.
Thank you, Dr. Ludwig. I'm a legal advisor with the Legal Bureau of ICAO. I was former deputy director, in fact, of the Legal Bureau. I asked for the floor to give a piece of information on a topic which was addressed, at least some concern was addressed, which is conflict of interest. And I would like to provide you with this information for those who are not aware of it, or to recall it for those who are aware. The conflict of interest in aviation safety has been a matter of concern in the organization. It was included in the work program of the legal committee and was extensively studied within the framework of the legal committee of ICAO. And it was the subject of an assembly resolution of ICAO. Guidance material was provided, and the resolution, which can be regarded from outside as a recommendation, is Assembly Resolution A39-8, called Conflict of Interest in Civil Aviation. I would quickly read only 2 paragraphs, which is the first one: recognizing that conflict of interest may hamper effective, independent, and impartial safety regulation of civil aviation, and thereby pose risks to the safety and security of international civil aviation. I will read another one. Considering that Annex 19, called Safety Management, and ICAO guidance material that I referred to, identify the need for states inter alia to establish a strategy to mitigate potential issues arising from conflicts of interest in civil aviation, and so on. The resolution was adopted. This is for your information, and I think it's relevant in the context of these wonderful presentations, excellent presentations made, and in addition to our colleague Bryan in ICAO comments. Thank you, and have a nice day.
Thank you, Silverio. These were more comments than questions, but if there is any comment from our panel, perhaps Bryan, being with ICAO, if you have anything to add to this.
I don't really, Dr. Weber, just thank Silverio for his comments. Thank you.
Thank you. John or Tommaso, any comment?
No, thanks.
No, I agree with that it's an issue, and that I'm glad it's being addressed in that way. Nothing else to say.
Thank you. I have no further requests for the floor. Silverio, you want to add something? No?
No, I
Okay.
was just trying to lower my hand. Thank you.
Okay. Okay, I saw your yellow hand up again. So I don't have any further requests from the floor for verbal questions. Maria, do you have any questions on the chat?
Yeah, but I see our time is up, so I will pick up on one question. It is a question from Leslie McIntosh, Director of Legal Service in IATA, and it is a question for all the panelists. So Leslie points out that the issues relating to the inherent conflict of interest in the delegation of approval authority was a subject of an ICAO legal committee study several years ago. And the question is whether there would be any benefit in reviewing and the conflict of interest issue again in the upcoming legal committee meeting in March. And it's a question for the three panelists.
All right. Shall we start with John? John, if you want to address that.
I'm the least qualified on this one, Professor. So I would, if you stuck it in an airplane, I would have a comment. I'd pass it on to my colleagues.
Okay, Tommaso, please.
I am less qualified than John.
Okay.
One level below.
Okay, Bryan.
So it's on me, but I would actually suggest, Dr. Weber, maybe just inviting Silverio Espinola again, if you would allow it, and if he has anything to say on the subject, since he's the expert, and I believe he was just talking about the review done by ICAO's legal bureau.
Yeah. Okay, Silverio, anything to add?
Oh, sorry, Ludwig, what was exactly the question?
Maria, can you please repeat that question?
So the question was whether there would be any benefit in reviewing the conflict of interest issue again in the upcoming legal committee meeting in March in ICAO.
Okay, good question. No, we consider within the legal bureau in the broader framework of legal committee that the work that was to be carried out by the legal committee has been accomplished. The guidance material has been published. It is, I think, in process of being produced in all ICAO working languages, which was missing. And at this point in time, it is considered that the subject has been disposed of. Although it still remains in the work program. So the question is pertinent, but I don't think that we will have much more to do or anything else to that. Thank you.
Thank you, Silverio. I think that we're very close to the time limit that we have. I will therefore try to have a very brief summary, which of course is almost impossible to do with a subject of the complexity that we have before us. But I maybe retain two items. And the first item is that perhaps the issue shows that lessons may be learned and synergies could be derived from the way in which safety is assured in space for future regulatory issues in relation to aviation. I believe that the methods that have been employed in relation to space could also be used in aviation safety regulation. And here I refer particularly to the idea that has been put forward by Tommaso for an independent body that would act in a supplementary fashion in relation to the institutions we have so far. And Tommaso also made some remarks about the way in which such a body has functioned in space with the structure that he has outlined. The second point that I would make is that obviously the conflict of interest issue is a very pervasive one and is a very difficult one to solve because on the one hand, the resources and the means of the regulatory bodies require the participation of manufacturers. And so this is a very difficult subject that I believe in the future much more emphasis needs to be put on. And I think the regulatory reform in the FAA has realized that. So these are the 2 points that I would suggest are takeaways from this webinar. And I will now ask Maria to make a few closing remarks. Maria, please.
Thank you, Professor Weber. In closing this session, I would like to thank very much our expert speakers, John and Tommaso, and our expert commentator, Bryan, for the excellent discussions. They certainly shed light to many aspects of today's topic. I would also like to thank Professor Weber for masterfully guiding these discussions, and I would like to thank Professor Jaco for all his help and support, as well as Kiran Vazhapully, who is a candidate at the Institute's Master of Laws program and who has also helped us today with this webinar. This webinar, as I mentioned in the beginning, was recorded and it is going to be available in approximately 2 weeks on our website after it will have been edited. On our website, you will also find the emails of our speakers and commentator, as well as their presentations. And for those who attended our first webinar or who are interested in it, the recording of the first webinar is already on the website. You can consult the website and you will find it there. Again, thank you all very much. Many thanks to our audience for being here with us today, and we will see you at the next webinar, hopefully, the details and the topic of which will soon be announced on our website. Goodbye and have a good day.